What's up, my stat stars? Michael Princhak here, ready to talk to you about the formula sheet that you will have during the AP Statistics exam. In this video, I want to go through every single formula on that formula sheet, talk to you about what it is, what it could do for you, and how you can apply it on the AP Stats exam. Now, there are three parts to that formula sheet. The first part is for descriptive statistics, the second part is for probability and probability distributions, and the third part is for sampling distributions and inference procedures. So we're going to walk through each part, going through all the formulas, talking about when you're going to use them and how you're going to use them, and some of them you might not even use at all. All right, let's get ready to dive right into them. The first section of the AP Statistics formula sheet covers descriptive statistics. Here we're talking stuff for Unit 1 and Unit 2. Basically, there's 6 formulas here dealing with mean, standard deviation of sample data, and then also correlation and slope and the least squares regression line for looking at the relationship between two quantitative variables. All right, let's look at them more specifically right now, one at a time. First up, we have the formulas for the mean of a sample and the standard deviation of a sample. Now, to be quite honest, these formulas are great, they're nice to have, but you're really never going to use them because your calculator could do all of it for you very, very quickly. Now, finding the mean of a sample is quite simple. You just add up all the values in your data set and divide by how many values you have. But the formula for standard deviation is a little bit more complicated, and most students don't want to do that by hand. So again, let me quickly walk you through how these formulas can actually be done for you using your TID4 calculator. So first we start off with a simple set of data, some quantitative data here, whatever these values represent. And then what we're going to do is we're going to go to our calculator. We're going to hit stat edit. That's going to enter the data into our calculator. So we're going to enter each value in one at a time, making sure that you please don't type in any wrong. So I tell kids triple check that you got them all in there right. Then you're going to slide over to, then you're going to hit the stat button again, slide over to calc and go to one variable statistics. And on this screen, it's going to ask you for the list of where your data is. So my data was in list 1, so I'm going to hit L1, but it could also be in L2, L3, L4, L5, L6. So make sure you choose the proper list. Now for the frequency list, you're going to leave that blank because there's no probabilities attached to either, or to any of our data values in our set. So leave that blank. If anything's there, just hit delete. And then you're going to hit calculate and your screen's going to look like this. At the very, very top is going to be the mean of your sample of data. And then go down a little bit and we're going to look for S. S is the standard deviation for your sample. Now, a lot of kids will see sigma and think that's the standard deviation. But here's the deal. If you have a population, all of your data, you have literally every single data value from your entire population, the formula for standard deviation is just a smidgen different than if you just have a sample. So that sigma in this data list here is if you did have all of the data from your entire population put into your calculator, then you'd want to use sigma for the standard deviation of your population. But that's usually never going to happen on the AP Stats exam. We're just going to have data from a sample, so we're looking for S, the standard deviation of our sample. Now the cool thing is there's actually more here. If you hit the down button, you could scroll down and you're going to get even more information. You get the 5-number summary that can be very useful in finding outliers and also making a box plot. So we get the min, the max, Q1, Q3, which can be found or could be used to make your IQR, and we also get the median. So using that one variable stats gets you a lot of information about a sample set of data, making that formula for the mean and standard deviation, well, kind of not needed. All right, next up are 4 formulas all dealing with linear regression. We actually have the formula for the least squares regression equation, y hat equals a plus bx. A is the y-intercept and b is the slope. Then we have the formula for correlation, which, to be honest, you're never going to need because you're either going to be given it or you could use your calculator to find it. Here is the equation of the least squares regression line that's used to predict a y value with a given x value. Now, there are 4 different ways that you could get this equation. This is really important to understand. One, I just straight up give it to you. This actually happens quite often on the AP exam, especially with multiple choice. They will just give you this equation. You just need to know that the first number, A, is the y-intercept, and the value being multiplied by x, the b, is your slope. Now, the second way that you could get this equation is through a computer analysis output table, which I'm going to talk to you about in 1 minute. The third way is that you actually find A and B by hand using the formulas provided to you on this formula sheet. And the fourth method is you just use your calculator where you enter in all the data and then your calculator will actually tell you the A and the B value to use for this equation. Let's walk through each of these different techniques right now. So here is a set of data for rail cars. So we have the number of rail cars that a train is pulling and the fuel consumption that that particular train is requiring. So we have all of our data here, and then we have a beautiful scatter plot that shows a pretty positive, somewhat linear relationship between the number of rail cars and the fuel consumption for that train. Now, one thing that I could do to find the least squares regression line for you is to just give it to you. So here it is. Y hat equals 10.677 plus 2.1495x. The y-intercept is the a and the slope is the b. Done. Just give it to you. That's pretty nice. The next option is that we get what we call a computer output analysis table. It looks just like this. Now there's a lot of numbers here that sometimes confuse kids, but all we're going to do is look in that very first column, and it goes in alphabetical order, A on top of B. So that first column is typically going to be labeled coefficients, or COEFF for short. But again, alphabetical order, A, then B. So there it is. A is the 10.677, B is the 2.1495, and you got everything you need. Now notice in this computer output table, you are not specifically given R, the correlation, which again, I mentioned that that formula for R is also in the formula sheet, but again, you're not going to need it because in all these computer output tables, R is given to you, but not exactly. What's given to you is R squared, but pretty easy to find R. All you got to do is take the square root of R squared and you'll get R. Just make sure you change it to a decimal. So here R squared is 96.7%. So we're going to take a square root of 0.967. Now, when you take that square root, don't forget it could be positive or it could be negative. So look at your slope. If your slope is positive, then your R is positive. If your slope is negative, then your R should be negative. Now, the third way that you could generate that least squares regression line is using the formulas. Now, on the AP exam, if they're going to ask you to use these formulas, there's a great chance that they're going to give you everything you need, which means they're going to give you R, the correlation, they're going to give you the mean of X, the standard deviation of your X data, and they're going to give you the mean and the standard deviation of your Y data as well. I've never seen a question on the AP exam where you actually have to go and get all that data, even though you could using your TI-84 calculator. Now, how do you use these formulas? Well, again, it's really just doing the math. So we always start off with slope first. So to find the slope B, you're going to take your R value, then you're going to multiply it by the standard deviation of Y divided by the standard deviation of X. So be very careful that you identify what are your Y variable, what is your X variable. We're always trying to predict the Y variable. In this case, we're predicting fuel consumption. So fuel consumption is definitely our Y variable. So the 22.76 has to go in the numerator. That could be a huge mistake if you make it. Once you calculate your B value, which again, we got 2.149, the same value that we got when I just gave you the slope, then we're going to go ahead and find the y-intercept using the formula. Now we have to do a little bit of maneuvering here because the formula they give you is y bar, the average y, equals A plus your slope times the average x. So all we got to do to solve for A is just subtract the average x times the slope over. So we take the average y, 87.2, minus the slope that we just found, times the average x, and that's how we can get our A value. But again, anytime you do have to use these formulas on the AP exam, I've seen it on multiple choice, I've seen it in FRQ every now and then, but they will give you everything you need. That's where you just got to go to the formula sheet to make sure you put everything you need in the right place. But identifying who's your average X and your average Y is really, really important. All right, the last option is that we actually use our calculator to get the least squares regression line. Now, to do this, you have to have your data. You have to have all of your X's, in this case, the number of rail cars, and all of our Y's, the fuel consumption. So what we're going to do is we're going to go stat edit, and in list 1, we're going to put our X's. In list 2, we're going to put our Y's. Double, triple check that you typed them in right and that they're all next to each other correctly. So every X value should have its corresponding Y value directly next to it. Then you're going to go to Calc, so hit Stat, slide over to Calc, and then you're going to select number 8, a least squares regression line, A plus BX. It's a linear regression, A plus BX. That's the way we like it in AP Statistics. Well, first you got to type in your list. So just make sure you hit L1 for your X data and L2 for your Y data. Leave the frequency list blank, and then when you hit enter, you'll get everything you need. Notice you get the A value, the B value, R, and you even get R squared. So everything is there needed for you. Pretty nice and simple. Now, for some reason, R and R squared are not coming up when you run a linear regression. All you got to do is go to Mode and go down to Stat Diagnostics under Mode and make sure it's turned on. If it's turned off, you will not see your R and your R squared. So those are the 4 ways that you could find the least squares regression line. The formula is given to you on that formula sheet, but again, it's nice where you can actually have the different options. And I will say in most cases on the AP exam, they're either going to give it to you or they're going to give you one of those computer output tables. Very rarely do you have to construct it by hand, and very, very, very rarely will you ever actually have to use your calculator to do all the work for you. So just make sure you know how to understand and read one of those computer output tables. The next section of the formula sheet, part 2, is for probability and probability distribution. This possibly could be the most useful section to you because for a lot of kids, probability is kind of like their toughest part. So here we got a couple basic probability formulas at the top. We got the formula for the probability of A or B. Then we got our conditional formula as well. Then we have the different distributions for a discrete random variable, a binomial random variable, and a geometric random variable. Let's walk through each of these formulas now and talk to you about some examples that could actually utilize them. So first up, we have the formula for, it's called the addition rule. This is the formula for the probability of A or B, and it equals the probability of A plus the probability of B minus the probability of A and B. A very useful formula because it has 4 really important things in it. It has A or B, A, B, and it also has A and B. But you also get something for free with this formula. You get a 5th value because the opposite of the probability of A or B, so if you do 1 minus the probability of A or B, is the probability of neither, no A or no B. So anytime you know every value in this formula, there's actually a 5th value that you know as well. That's the probability of neither A nor B. All right, let's actually show you an example where this formula would be used. So here we are given that the probability that a student takes physical education is 25%, the probability that a student takes a Spanish class is 45%, and the probability that they take either physical education or Spanish is 65%. What is the probability that they take both physical education and Spanish? So again, we're given, of those 4 things in the formula, we are given 3 of them. So we're simply going to utilize our formula and make some replacements. The probability that they take physical education or Spanish was given to us is 0.65. The probability of physical education was 0.25, plus the probability of taking Spanish was 0.45. And then that last part, the probability of both physical education and Spanish, we don't know. So we're going to leave that as an X. Typically, it's what we do. We're trying to create a little algebraic equation. We don't know something, we make it an X. Now we just have to do a little bit of solving, subtract the 0.25 over, subtract the 0.65 over, and we get negative 0.05. But of course, we still have a negative on the other side in front of that X, so divide both sides by negative, and we get that the probability of both taking physical education and Spanish is about 5% or 0.05. This formula could also be used with a two-way table. So here's an example of a two-way table where this formula is going to come in handy. A random sample of 2,500 people were asked their highest level of education and how they primarily get their news. And in this table, we see lots of options for both of these variables. Now the question is, if a person from this sample is picked at random, what is the probability he or she gets news from newspaper or is a college graduate? All right, so the first thing we're going to do is utilize our formula. The probability of newspaper or college graduate is going to be the probability of the newspaper plus probability of college graduate minus the probability of both. And now we're just going to look at the table and fill things in. The probability that somebody is picked that gets their news from the newspaper is 442 out of 2,500. The probability that somebody is a college graduate in this sample is 693 out of 2,500. And the probability that somebody is both, that's the overlap, gets their news from the newspaper and college graduate, that's going to be the 188 people out of 2,500. Now they all have a common denominator, so all we got to do is add and then subtract, and we get 947 out of 2,500 will be 0.3788. So it's about a 38% chance that a person picked at random from this sample is going to be getting their news from the newspaper or a college graduate. But again, it's a pretty nice, simple use of the formula. Next up, we have the conditional probability formula. This is trying to find the probability of an event A occurring on the condition that event B has already occurred. Now it's a nice, not too bad formula. It is a fraction though. On top is the probability of A and B, and the denominator is the probability of just B, the condition. All right. So to utilize this formula, let's go back to our physical education Spanish problem. So same setup, 25% chance a kid has physical education, 45% chance that they have Spanish, and there's a 65% chance that they have physical education or Spanish. Now the question here is, given that a student takes Spanish, what is the probability that they also have physical education? So first, recognizing this is a conditional question because of that word given. So we're finding the probability that they take physical education. That's literally what the question said. But after that line is what was given, we know that the person is taking Spanish. So again, I'm just going to set up a little equation here using the formula. So in the numerator is going to go the probability of both physical education and Spanish, which we actually already found in the previous problem to be 0.05. Then we're going to divide by the probability that they take Spanish, which we directly know from the problem is 0.45. Divide and we get 0.111. So about 11% chance that given a student takes Spanish, or given that they're in a Spanish class, it's about 11% chance they're also taking physical education. But it's really just about recognizing that that's a conditional probability formula. Then we can go ahead and use the formula. Next up, after the basic probability formulas, the probability for A or B and the conditional probability, are 3 rows for the probability distributions. We have a row for discrete, a row for binomial, a row for geometric. Now, please note that binomial random variables and geometric random variables are also discrete random variables, but they're just special situations that have special formulas just for them. All right. So the first row here is for the mean and the standard deviation of a discrete random variable. Now we have a formula for the mean, mu sub x. We have a formula for the standard deviation, sigma sub x. But I'm going to be honest, we really don't need these formulas because your calculator could do the work for you. Now the formula for the mean is quite easy. All you got to do is take each outcome for your random variable, multiply by its probability, and then repeat that every outcome times its probability, and then add them all together. That's not too time consuming, but the formula for standard deviation for a lot of kids is a little bit confusing and time consuming. That's why we're going to let our calculator do all of that work for us. So here's an example. A company has 5 telephone lines. Let x be the random variable. How many of those telephone lines are used at any given time? Now, this is a discrete random variable because there's a distinct set of outcomes. 0, 1, 2, 3, 4, or 5 phones could all be used. And underneath each of those outcomes, we have the associated probabilities that were given to us. So to find the mean and standard deviations, quite easy. First thing we're going to do is we're going to hit stat edit. We're going to enter this data into our calculator. In list 1, we're going to put our outcomes 0, 1, 2, 3, 4, and 5. And then right next to each of those outcomes in list 2, we're going to put the corresponding probabilities. Once again, double, triple check that you typed them all in right, or you're going to get something wrong. Next up, we're going to hit stat and slide over to calculate and choose one variable stats. Now, it's really important that we first enter the list of our outcomes, which is list 1, and then underneath that, because each of our outcomes has a frequency or probability attached to it, in the frequency list, we do want to put L2 here, or list 2. Please make sure that when you're creating a probability distribution in your calculator and you go to one variable stats, you got to include that frequency list. Then you're going to go ahead and hit calculate, and you're going to get the mean and the standard deviation. So at the very, very top is the mean, 1.6. That means on average in the long run, there are 1.6 phone lines being used, but sometimes there's more, sometimes there's less. So the standard deviation sigma is here as well, 1.56. All right, so not too bad. And again, so you really don't need those formulas because the calculator is going to do a lot of the heavy lifting for you as long as you know how to do it. All right, next up are the formulas for the binomial distribution. Now, a binomial distribution is where we have a probability of success given to us, and then we also have a set number of trials given to us as well. And it's important that every one of those trials is independent of the next, and that the probability of success doesn't change as we go throughout the problem. It's got to stay consistent. So on the far left here, we have the formulas for the probability, how to find the probability of a certain number of successes out of n trials. In the middle, we have the mean of that binomial distribution. And on the far right, we have the standard deviation of that binomial distribution. But just note that these formulas can only be used if you've confirmed that you have a binomial distribution. All right, so let's actually walk through a problem where you're going to see this all used. On any given day, the probability that Mark misses the bus is 20%. Each day is independent of the next. In a sample of 10 school days, let x be the random variable of how many times he misses the bus. So we're given two things here, which makes it a binomial model. We're given the probability of success, 20% chance he misses the bus. I know that doesn't sound successful, but that is what we're looking for, and success is simply what we're looking for. We're looking for him to miss the bus. And we're given a set number of trials, 10 school days. So over those 10 days, he can miss the bus 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, or 10 times. Now the question is, what is the probability he misses the bus exactly 3 times? So let me show you how that probability formula that they give you is going to work. So here it is generically. That first section right there, the parentheses is how many different ways it can happen. So we have 10 different days. How many different combinations are there where 4 of them are successful, meaning he misses the bus. So we have 10, choose 4. Then we have our success, 20% raised to 4 because we need 4 of those successes. And then the remaining 6 trials are going to be failures. 10 minus 4 is where we get that 6 from. So that's the 0.8 to the 6. So we got number of combinations, 10, choose 4. Success, 0.2, 4 times. And then we have the remaining 6 are all going to be failures, which is 0.8 to the 6. And using our calculator, however you want to calculate that, we get 0.0881. Now, if you're really good at using your calculator, you could do binomial PDF to get this value for you. Or you might have to do it by hand. It's all depending what you want to do, but that's explained in a later video. I just want to make sure how you see how this formula works. All right, let's do the same problem, but this time let's find the mean and the standard deviation for x using those 2 formulas as well. But again, you got to make sure it's a binomial distribution problem, which this one certainly is. So to find the mean, we're just simply going to take n times p, and to find the standard deviation, we're going to take a square root of n times p times the opposite of p, or our failure rate, 1 minus p. So pretty nice and simple, not too painless here. So for the mean, we have 2, which means in the long run, out of 10 days, if he looks at 10 days, on average, he's going to miss the bus 2 out of those 10 days. But some days, some different times it's going to be more, sometimes it could be less. So that's why we get a standard deviation of 1.265. So overall, not too bad utilizing those formulas. All right, next up we have the formulas for the geometric distribution here. So geometric distribution is where we also are given a probability of success P, but we're looking simply for our first success. We don't care about after that, we're just looking for how many trials does it take to get our first success. All right, so we have the formula to find the probability of any particular outcome on the left. In the middle, we have the formula for the mean of a geometric distribution. On the far right, we have a formula for the standard deviation of a geometric distribution. All right, so here's our example. Let's go back to our friend Mark, who has a 20% chance to miss the bus. But now we're not given a set number of trials. We're just looking for x to be the random variable for the number of days until he misses the bus for the first time. So that's geometric. We're not given a number of trials. We're just told, hey, we're looking for how many days until he gets that first success, in this case, the first missed bus. So let's talk about how we could use that probability formula. So what is the probability the first time Mark misses the bus is on the 6th day of school? Well, that's actually pretty simple utilizing this formula. This formula looks kind of more complicated than it really is, but we have to start off with failures. So that means that the first 5 days, he did not miss the bus, which would be 80%, 80%, 80%, 80%, 80%. So 0.8 to the 5th. And then on that next 6th day, he, missed the bus. That would be the 0.2. So it's really, really simple. We don't have to worry about any combinations here because it's very, very specific. If we want the 6th day to be the first day he misses the bus, the first 5 he did not miss the bus, and then he finally missed the bus. Nice and simple. No need to actually really do any kind of major work here. It's just understanding the process and recognizing it is a geometric random variable. All right, what about finding the mean and standard deviation in this situation where x is the number of days until he misses the bus for the first time? Well, once again, we have these 2 really, really easy formulas on that formula sheet. All we got to do is kind of plug and chug. So 1 divided by 0.2 is 5, which means on average, if we were to, have him wait and see how many times it takes him to miss the bus for the first time and then do it again, do it again, do it again. On average, it's going to take 5 days to get his first missed bus. But sometimes it could take more and sometimes it could take less, which is why we have a standard deviation there as well. Utilizing that formula, we get 4.472. So overall, not too bad, but there are a lot of formulas there with the probabilities, so make sure you know how they all work. A lot of kids get really confused with binomial, geometric, and even just plain old discrete. So really utilize this section on that formula sheet to help you when you get to a problem that you recognize is binomial or geometric. The third section of the AP Stats formula sheet covers sampling distribution and inference statistics. This is also going to be a very useful section to you as you go throughout the problems and deal with anything that deals with statistical inference. So this is going to be the very bottom of the first page and then the whole second page of that formula sheet. All right, so the first thing that they give you is the generic formula for a standardized test statistic. This is going to either be a z-score or a t-score if you're conducting a significance test. Now here is that generic formula. Now notice that they don't call it z or t because it could be one or the other, but the generic formula for a standardized test statistic is taking a sample statistic minus a population parameter that you were led to believe is true, and then you're going to divide by the standard error of the statistic. All right, so here's a quick example. If you are working with proportions, which means you're going to need a z-score, and your null is that the true population proportion is 30%, and the alternative is that you think it's less than 30%. So just showing how we're going to be utilizing this formula here, we're going to take our sample statistic. Let's just say our sample showed 25%. We're going to subtract the null proportion, that what we believe the population parameter was to be, that's the 30%, and we're going to divide by the standard deviation in this case, because we have to assume that that 30% is true. So we're going to divide by the square root of 0.3 times 0.7 divided by 550. But that's just a rough example to show you exactly how this formula would be used to make sure you remember how to get that z-score or that test statistic for a significance test working with proportions. Now, what about an example with means? Let's just say we have a null that the true population mean is 42, an alternative that we believe is greater than 42. So once again, to get a test statistic here, we're going to use a t-score, and I'll explain why in 1 second. But we're going to take our sample mean that we actually found, so maybe our sample mean was 45.6. We're going to subtract the null population parameter, that what we thought to be true from the null, that was the 42, and we're going to divide by our standard error. Now, when we're working with means, the standard error is going to be taking the standard deviation of our sample, S, divided by the square root of our sample size, N. Now, again, that's exactly why we're using a t-score here, is because we're using S, the standard deviation from our sample, instead of the population standard deviation, which we're not going to know, and that is why the t-distribution is just a little bit more accurate. So let's just say that our sample had a standard deviation of 6.5, and we're going to divide by the square root of our sample size of 35. Again, this is just a generic problem, but just showing you how we can actually utilize this generic formula. You just have to remember it's a test, it's a sample statistic, either a p-hat or an x-bar, or maybe the difference between two p-hats, the difference between two x-bars as well, minus what you believe to be true from that null hypothesis, whether it's a p or a mu, and then divided by that standard error. Now, speaking of the standard error, there's a lot of different standard error formulas, and a lot of kids might not want to memorize them, but on the second page of the AP Stats formula sheet, they are all given to you. So the first, we have a box for sampling distributions for proportions. So we have a row for one population proportion, and we have a row for the difference between two population proportions. So notice that on that far column is the formulas for standard error of the sample statistic. So in that generic formula for your test statistic, the denominator is that standard error, and you just got to make sure you choose the right one. If you're working with sample proportions, here you go. If you're working for the difference between two population proportions, here you go as well. So it's all there for you. All the formulas are here for you. It's super nice. Now, if you are working with a sampling distribution, like you're not really talking about inference, you're not doing a significance test, you're just talking about the mean and the standard deviation for a sampling distribution, then that's what these first two columns are for. This is not standard error. This is the mean of a sampling distribution for a population proportion, and then also the standard deviation for that sampling distribution. So again, there's a lot of multiple choice questions that just ask you to build the sampling distribution for a population, building a sampling distribution for a sample proportion. And here's all the formulas that you're going to need. It's really, really simple. So we have the mean, which is the center, the spread, which is the standard deviation. And then the other thing is the shape. Don't forget about the shape, but that should be normal as long as our sample is big enough. And then right below that, we also have the formulas for working with sampling distributions for sample means. So again, as long as we are building a sampling distribution for sample means, we got the formulas for the mean, the standard deviation. The first row is for looking at one population, and the second one is looking at for the difference between two populations. But look at that far right column for standard error. So again, if you're using that generic formula for a test statistic, in the denominator is the standard error formula, and you say, well, I know I need a standard error, I just don't know which formula I need. Well, just jump to these here and get the right one. All you have to do is decipher, am I working with proportions? That's going to be that first box that we just looked at. Am I working with means? That's going to be what we're looking at right here. And then you got to decide, am I working with one or am I working with two samples? That way you use the right row. Overall, not too bad. All right, next up there is the generic formula for a confidence interval. The most generic formula for a confidence interval looks like this. It starts off with a sample statistic. That could be a p-hat, that could be an x-bar, a sample mean. That could be the difference between two sample proportions or the difference between two sample means. That could even be a sample slope b as well. Then we're going to add and we're going to subtract the margin of error. Now, the margin of error for a confidence interval is the combination of two things: your critical value times your standard error of the statistic. So the critical value is either a Z star or a T star that's completely based on your level of confidence. Typically you want to be 95% confident, so make sure you know how to use invert norm or invert T on your TI-84 calculator to go and get that Z star or T star. Then we're going to multiply that by the standard error. And guess what? That's where you'd want to use those same two formula sheets that are going to give you all of the different standard error formulas you need. The same standard error that was in the denominator of our test statistic is the standard error that we're going to need here in a confidence interval as well. You just have to once again decide, are they asking me to do a confidence interval for proportions? Look at this chart right here. Are they asking me to do a confidence interval for mean? Look at this chart right here. And then make the decision, are there one or are there two? Are we looking for the difference between two sample means? Or are we looking for just a single sample or a single sample mean? So make sure that all makes sense to you. But again, that formula for confidence intervals is very generic, but if you know how to use it, it's actually really, really simple to use, especially when all of the formulas for standard error are given to you on that second page of the formula sheet. Now, the next thing that's given to you on that formula sheet underneath the test statistic formula and the confidence interval formula is the test statistic for a chi-square test, which is of course chi-squared. Now here we're taking the observed values from categorical data that's counted minus its expected value, all squared, divided by the expected. And we're going to add them all together because you might have several different cells or several different categories, and you got to get the chi-squared for every single one of those categories. And again, it's pretty simple to do. You just got to take the observed minus the expected squared divided by the expected. A lot of kids, flip things around this formula, so it's really nice to have it on the formula sheet. That way you can just look at it and make sure you're doing it all in the proper order. Now, the final thing on that AP Stats formula sheet is sampling distributions for simple linear regression. Now, there's lots of formulas here. The first two columns are for the mean and the standard deviation of a sampling distribution for sample slopes. Basically, if we think about a model, it shows all possible sample slopes. Then we also have the standard error for the sample slope as well. But I gotta be completely honest with you, there's very little questions on the AP Stats exam that utilize simple linear regression sampling distributions, so don't expect to use these formulas too much. But on the few questions that do ask you questions about sampling distributions for sample slopes, you're gonna be given one of these computer output tables where all this information is given to you. So what could come up on the AP exam dealing with slope? Well, they might ask you to construct a confidence interval for the population slope. Now, here is that formula. Again, it's the same generic formula for a confidence interval we talked about already. We're going to take our sample slope B, we're going to subtract our critical T star, and we're going to multiply by the standard error. Or if we're going to conduct a test of significance based on slope, typically the null is that the population slope beta is 0, meaning that there is no relationship between the two variables. And the alternative is that there is a non-zero slope, which basically says that there is going to be a slope between these two variables. Now here we're going to be using our generic test statistic formula. So we're going to take our sample slope, our statistic B, we're going to subtract 0. 0 was from that null hypothesis that there was no relationship. And then we're going to divide by the standard error. But again, the key thing you need is the standard error. Now that formula for standard error for sample slope is given to you in that chart I showed you on that formula sheet, but you're never going to need it, trust me, because in most cases you're going to be given a computer output table just like this. Now, it's important that you first recognize where everything is at. So first we have the slope. Just remember, in alphabetical order in that very first column, A and then B. So B is that bottom number, in this case, negative 0.00714. Right next to it, there is a column for standard error. This is the standard error for the sample slope. You do not have to even utilize the formula. Again, the formula is given to you on the formula sheet, but trust me, you're never going to need it. The standard error is right here for you. You don't even have to do any work. It's just staring at you in the face. It's literally the number right next to the slope. So if you are asked to construct a confidence interval and you got your sample slope, you got your T star, and you need your standard error, all you gotta do is look in the chart. It's right there next to the slope. Now, what's also cool is even if you're gonna do a test of significance for slope, you also have the T-score right here. It's right next to the standard error under the column labeled T-stat. So you do not even need the formula to figure out what your t-score is because it's going to be given to you in one of these tables. It's just make sure that the t-star that's given to you here, or excuse me, the t-score that's given to you here is based on a null hypothesis of beta being 0 and an alternative that it's not equal to 0. And then check out, you get one more thing here as well. You get a p-value literally right next to that t-score. So basically, there's very few questions on the AP exam that are going to deal with slope, but the ones that do, everything is given to you in one of these computer output tables. So if you are ever asked some questions about slope, whether it be a confidence interval or a test of significance, trust me, everything is given to you in one of these computer output tables. You really won't need any of the formulas. All you got to do is know where to find the slope, the standard error for the slope, the t-score, and the p-value, and it's all there for you. So nice and simple, really making you not have to do a ton of work at all. So really those formulas for slope, you're not going to really need, to be quite honest with you. So that's it. That's the formula sheet for the AP Statistics exam. Hopefully I went through every single one of the formulas and gave you an example of how you would use it, where you could use it, and how you may not actually even need it at all. If you're looking for more practice and stuff to do to prepare for the AP Stats exam, please check out the Ultimate Review Packet for AP Statistics. Link in the description below. There's tons of examples, study guides over every single unit. That way you can continue to practice for the exam and make sure you're going to get that perfect 5 you may want. All right, see you in the next video.